Hello guys, welcome to Heavatek ICT Solutions. On today's video, we'll be working on an Asus laptop motherboard. This is an Asus board with model number X202E. This laptop motherboard came in as a no power. It came from a local repair shop. I'll be taking us on the steps on how to follow and bring this laptop motherboard to life. The power adapter is already plugged in. Okay, it's plugged in, and we'll start by troubleshooting the VIN line and then proceed to other parts of the motherboard. On the VIN line here, we have 19 volts. This is the adapter in, and then we also have the 3.3 volt always present. Our 3.3 volt is present. We also have our 5 volts present. Our 5 volt is present. Okay, it therefore means that the 3 volts and 5 volt circuit is working properly. Okay, and therefore it is outputting the 3 volt and 5 volt always voltages. So the next step, we are going to go to our BIOS chip and check if it has power, if it's actually working properly. Okay, this is our 8-pin BIOS chip. On pin 1 here, which is the chip select pin, we have 0 volts. On pin 2, which is the data output, the data out, we have 0 volts. On pin 3, which is the write protect, we have 3 volts. Okay, on pin 4, this is ground. It's supposed to be 0 volt. Yeah, we have 0 volts. On pin 6, which is what the data input, we have 0 volts. On pin, this is pin 5, which is the data input. Pin 6 is a clock. For the clock signal, we have 0 volts. Pin 7 is a hold pin. We have 3 volts. We have 3 volts on pin 7. On pin 8, which is a VCC, we also have 3 volts on pin 8. Alright, guys, this motherboard is dead. It is in an idle state right now. It is in a reset state. Pin 1, which is the chip select pin, is supposed to read 3 volts. Alright, this is the reset pin, chip select pin. It is in an idle state. When it is an idle state, it is supposed to read 3 volts because the EC chip has not released it from the reset state. Alright, when it is released from the reset state, it goes toward 0 volt. It goes from 3 volt to 0 volt. Alright, and we are reading 0 volt in its idle state. It means there is a problem somewhere, particularly the EC chip. The EC chip has not released its reset signal. Alright, so we are going to move to the EC chip and check if the EC reset signal is out. Okay guys, this is the board view for our motherboard. Alright, This is the board view for our motherboard. We are going to follow the traces on the board view to see the connections on our motherboard. Alright, right here is the SPI chip or the BIOS chip. Alright, this is pin 1. This is pin 1. Alright, this is the chip select pin. So we are going to click on it and see where it is connected to. Alright, we are going to click on it and see where it is connected to. We have selected our pin 1. There's no visible connection from this other side, so we are going to flip our motherboard to the other side and look at it. Okay, we have a connection to this other side. Okay, look at the connection here from the other side of the motherboard to this side. It is connected on this test pad here. Alright, so this is SPI chip select, active low logic, and then outputting to this other side of the test pad we have the EC SC low logic, it's active low, and then connecting to this resistor here, R3050. Okay, and then from here to this resistor it is connecting to our EC chip. Okay, it is connecting to our EC chip on pin 101. It is connecting to our EC chip on pin 101. So this EC chip here is supposed to output the reset signal for our SPI chip pin 1. Alright, we are supposed to have 3 volts outputting on this chip 100, and this outputting on this pin 101, and for this signal to be active, the EC reset signal has to be present. Okay, the EC reset signal has to be present. So we are going to check the EC VCC to be sure that the EC chip is actually receiving its working voltage. From there we'll now check for the presence of what? EC resets. Alright, we check for the presence of EC resets. So let's look for EC VCC on our pinout. This is this is EC reset. Our EC reset is on pin 14, right? Okay, our EC reset is on pin 14. But before checking for EC reset signal, we are going to check for EC VCC, the 3 volt always voltage that supplies the EC for it to work. Okay, now one of the pins is on pin 26. Let's trace our EC VCC on pin 26. Now we can see that the signal is going out to different components. Alright, we can test our EC VCC on R3021. We can also check it on this resistor network here on pin 1 and pin 3. Alright, we have 3 volt always EC. Alright, we can also check that signal on this resistor here resistor 3008. All right, we can also check that signal on this resistor here. All right guys, so let's go ahead and probe those components that are connected to our EC VCC line. Okay guys, this is our EC chip right here. As it was earlier shown on the board view, we can probe the network resistor. Right, we can probe the network resistor on pin 1, and pin 3 for our EC VCC. We can also probe this resistor R3021 here, all right, to check if our EC is receiving its working voltage. So let's probe and check. This is the network resistor here. Okay, this is our network resistor. This is our network resistor. Okay, this is supposed to be pin 1. All right, guys, we have our 3 volts on network resistor. Right. Okay, now let's probe the other resistor 3021. We also have our 3 volts always on that resistor. It therefore means that our EC chip is receiving its working voltage and it is working at this stage, but it needs to exit its sleep state or its reset state. How will it do that? By the availability of the EC reset. It is on when the EC reset signal is released before the chip select pin will receive its working. It will receive its voltage to enable it prepare for data transmission. All right, so we are going next to now probe the EC reset pin and see the circuit controlling that pin. All right, so let's move to our board view. All right, let's check our EC reset pin. Our EC reset pin resets. All right guys, we have our EC reset pin here on pin 14. All right, so let's check and see the connection. This is our EC reset pin. It's going to this and 2 capacitors here, capacitor 3011 and capacitor 3201. Right, this is a connection, direct connection to this EC reset pin. All right, now let's flip the board to the other side and see. Okay, this is a connection, direct connection to the EC chip. Flipping the motherboard, we have the circuit controlling the EC reset signal. All right, okay, this is the test part here. We can check our EC reset on this test point. All right, and then there's also a diode here connected to this circuit. We have a pull-up resistor here. Okay, we have a pull-up resistor here for the EC reset signal, and then the pull-up resistor is connected to this MOSFET. All right, it is connected to this MOSFET. This MOSFET is responsible for generating the EC reset signal. All right, guys, so we are going to first of all probe the EC reset signal. If it is not present, we now concentrate on this MOSFET that is responsible for generating the EC reset signal. If the EC reset signal on this MOSFET is present, then the problem should be the pull-up resistor or this diode here, all right, contained in this circuit. So let's first of all check for the EC reset signal. All right, this is the circuit controlling the EC reset signal. Okay, on our board view we have our diode here, we have our test point here, okay, and then network resistors here. We have a series of network resistors here, okay. All right, so we also have a test point here for us to test our EC reset signal, and then this is the the MOSFET that is responsible for generating the EC reset signal. So let's go ahead and test the EC reset signal at the test point. Now, this is our diode. Okay, this is our diode here. This is our MOSFET. Guys, you can see, looking at the MOSFET responsible for generating our EC reset signal, you can see, just looking at it, you can see that the MOSFET is rusted. Guys, look at this, it is rusted. So I believe this is likely the cause of the EC reset not generating. But nonetheless, let's go ahead and test for the EC reset signal. Okay, this is our network resistors, this is the test point. Okay, this is the test point. Guys, we have nothing here, we have nothing. Okay, looking at the multimeter, I have 0 volts. It means the EC chip is still in a reset state. All right, it has not initialized because of what? The EC reset signal is absent. All right, it is absent. Nothing on our diode, nothing here, nothing here. Pull up resistor, nothing. Okay, nothing. So guys, let's look at the MOSFET controlling the EC reset signal. Okay, now this is a MOSFET here. Pin 6 is supposed to what? Assert the EC reset signal. On pin 6 we are supposed to have what? The EC reset signal on pin 6. Okay, pin 1 is here, pin 2 here. This is the gate supply for the MOSFET, EC reset gate. This is also EC reset gate, and then we are supposed to have what? Our output here on pin 6. So now let's go ahead and probe pin 6 on this MOSFET. Let's go ahead and probe pin 6 on this MOSFET and see if we have our EC reset signal. Afterwards, I'm going to clean up that portion of the motherboard, and then if still does not come up, I will now replace this MOSFET here. All right. Okay, let's check if our supply is still present. Okay, 19 volt is still in. So let's go here on pin 6. On pin 6, this is pin 1, 2, 3. One, 2, 3, 4, 5, 6. We have no volts on this pin 6, guys. There's nothing on pin 6. It means this MOSFET is not generating the EC reset signal. This pin 2 and 3 are supposed to have the gate supply. Nothing on the gates, nothing here. Nothing here. Okay, guys, coming back to our board view, we are supposed to receive our EC reset signal on this pin, which is pin 6, right? And then the supply voltage is supposed to be the supply voltage for the MOSFET that is supposed to generate the EC reset signal is supposed to come on pin what? On pin 2 and pin 3. Okay, it's supposed to be on pin 2 and pin 3, which is what? The EC reset gates. All right, the EC reset gate pins for the MOSFET is pin 2 and pin 3, and the component supplying this gate voltage is what? Our R3202. This is the pull-up resistor supplying the gate voltage for this MOSFET. Okay, while probing, we did not have there was no voltage on pin 2 and pin 3. Okay, there was no voltage on pin 2 and pin 3. We had only voltage on what? Pin 5. There was no voltage on pin 6, which is supposed to be what? The EC reset signal. Now, coming back to the component that is supposed to serve as what? The supply for our MOSFET, which is what? The R3202 resistor. On this resistor, we have what? Our 3 volts always EC. This voltage is supposed to come from the 3 volts always EC. All right, and then supply to what? The MOSFET as what? EC reset gate. This is supposed to be the voltage for the EC reset gate that will now enable the MOSFET to generate our EC reset signal. But while we were probing, we did not receive any voltage on this gate pin here. Okay, we did not receive any voltage on this gate pin, and this resistor is supposed to be our supply. All right, so I am going to first of all clean up the MOSFET that is shown rust all over it. I'm going to clean it up. All right, and then also measure the resistance of this this resistor. Okay, let's see the value of the resistor. Our resistor here is supposed to be a what? A 1 mega ohm resistor. Okay, it's supposed to be a 1 mega ohm resistor. This is the resistor that is supposed to supply our gate voltage. Okay, it is the resistor that is supposed to supply our gate voltage. So I am going to clean up the MOSFET, the rust on the MOSFET, and also check the resistance of this resistor. It is supposed to be rated a 1 mega ohm resistor. I'm going to check the resistance, and know the reason why it is not what transferring this 3 volts always on this side to this other side in order to supply this MOSFET, because the MOSFET needs what, the gate voltage, for it to what, output our what, EC reset signal. Okay guys, I have cleaned up the rusted MOSFETs and also desoldered the pull-up resistor that is supposed to serve as a supply for this MOSFET. Okay, this was the location of our MOSFET. Okay, all right, this was the location, this is our MOSFET, and this was the location of our pull-up resistor. I desoldered it from the motherboard. Look at it here. Okay, this is it here. This was supposed to be rated 1 mega ohm. Okay, but upon measuring, it is rating over 2 mega ohms. It's rating 2 mega ohms. The resistance has increased or shot up, therefore preventing the voltage, all right, the 3 volt always from transferring from this end of the resistor to this other end in order for it to supply the MOSFET that is supposed to generate our EC reset signal. Okay, so I'm going to look for a 1 mega ohm resistor and replace this other one that has increased its resistance value from 1 mega ohm to over 2 mega ohms. Okay, and see if we can have this voltage from this other side move to the EC reset gates. Alright guys, I have changed the resistor, the pull-up resistor that is supposed to transfer the 3 volt always to the gate of this MOSFET and subsequently output our EC reset signal. So I have connected the adapter. Let's check our voltage here. We have our 19 volt adapter. So let's check our EC reset signal. Guys, our EC reset signal is now present. Okay, now let's check our chip select pin. Our chip select pin is now outputting 3.2 volts, and then our CPU is actually warming up. It's actually warming up, guys. So let's now connect our fan and see if we can have a fan spin. Okay, let's see if we can have a fan spin. All right, okay guys, as you can see, we now have a fan spin. Our fan is spinning. Okay, our fan is spinning, guys. Our fan is spinning. As you can see, our fan is spinning, guys. Okay, our fan is spinning. So checking on our chip select pin, we now have our 3 volts chip select. Guys, we have our 3 volt now. So this means that the EC chip has initialized and has taken the BIOS chip out of the reset state, and there is communication going on now. So I am going to mount this motherboard on the laptop frame and see if we are going to have a display. All right, okay guys, As you can see, the motherboard is mounted to the frame. We have our fan spinning, okay, and then this is our display. Okay, we have a display guy, we have a display. So this is a fix. Thanks guys for staying to the end of this video. I'll see you in another one. Please do not forget to subscribe and also share our videos. Thank you.